Okay, so today we are in our third lesson in this topic of matrices and matrix algebra, and several things that we're going to do that are going to be helpful. None of this is overly difficult, but it is important if you're going to work with matrices in the future. So we'll start off with some really easy stuff. How to add or subtract two matrices. So your book is going to give you something like this. They're going to give you some matrices to use and then an operation to perform. So adding two matrices together is about as easy as it gets. You just have to confirm that the dimensions of the two matrices are the same. So let's just talk about dimensions for a second. When I state the dimensions of a matrix, like this matrix A, I always state it by rows and then columns. So I call matrix A a 2 by 3. That's not 2 times 3. It's literally read as a 2 by 3 matrix. You always state rows, then columns. And as long as the two matrices that you want to add or subtract are the same dimensions, then it's really just as simple as matching up the corresponding elements and performing the operation. So if I'm going to add A and B together, I do 0 plus 4, I do 3 plus 1, negative 5 plus 0, 1 plus negative 2, 2 plus 3, and 6 plus negative 2. So you match up the elements that correspond to each other and either add or subtract. Okay, letter B is an example of what is known as scalar multiplication. Scalar just means we're basically taking a number and we're multiplying that same number by the entire matrix. Think distributive property with matrices. All right, so I'm going to do the 3 times A part first. Remember, we multiply before we add or subtract. So this would be the result of 3A, 3 times each element separately. 3 times 0, 3 times 3, 3 times negative 5, 3 times 1, 3 times 2, 3 times 6. That is called a scalar product. Now we'll do the same thing. I'm going to put the minus sign, and now let's do 2 times the B matrix. 2 times 4, 2 times 1, 0, negative 4, 6, negative 4. And now we perform subtraction. So just like we did with addition, you just match up the corresponding elements. Obviously be careful with subtracting negative numbers. So 0 minus 8, 9 minus 2, negative 15 minus 0, 3 minus negative 4, 7, 6 minus 6, and 18 minus negative 4 is 22. So that's our final answer. Questions so far? Probably not. Everybody good? Okay, now let's talk about multiplying matrices. That's a little different animal. Not hard, but there's some things we have to be aware of before we can multiply. It may not be possible to multiply matrices together. Here's how you'll know. Look at the dimensions of each matrix. So the dimensions again for matrix A, it's a 2 by 3. And then matrix C over here is a 3 by 2. Always do rows before columns. The way you'll know if matrix multiplication is possible is when you write the dimensions like this. And by the way, matrix multiplication is not commutative. So multiplying A times C is not the same thing as doing C times A. Like with regular numbers, we can change the order around and get the same result. That is not true with matrix multiplication. So keep the dimensions in the same order that the letters are given and compare the inside numbers. If the inside numbers match, then you can do the multiplication. If they don't match, then it's not possible. So, two things. Check to make sure the inside numbers match, and if they do, these outside numbers will tell you the dimensions of the product, what your answer should look like. So when I'm first starting out with people showing matrix multiplication, I just encourage you to go ahead. If multiplication is possible, let's just make ourselves a blank 2 by 2 matrix, and we're going to work on filling in the blanks. Okay, so here's how matrix multiplication works. We're going to take, first of all, it's always row times column. Get that fixed in your mind. You always multiply row times column. So think of it this way. This element of my answer is in position row 1, column 1. So to get this answer, I'm going to use row 1 times column 1. And you just match up the elements and multiply them together. So it works like this. To get this top left answer product, I'm going to do 0 times 4. I'll just write it out down here. Plus 3 times 6. Plus negative 5 times negative 2. Okay? Row times column. And then you're adding up these little products that are formed. So 0 plus 18 plus 10 is 28. Okay? So to get the product for row 1, column 2, just think, well, that's going to require row 1 of A times column 2 of C. And match up the elements. 0 times 1 plus 3 times 2 plus negative 5 times 3. 6 plus negative 15 is negative 9. And now we'll work on the bottom row. This is row 2, column 1. So I'm going to use row 2 times column 1. And I'll let you go ahead and see if you can fill in those bottom 2 parts of our product, the product matrix. Okay, seeing really good things. The bottom left number of our product should be 4. I think I saw where most of you got that. Any questions on how we got 4? And then the bottom right part of our product, I believe it's 23.
Yeah, how do you get those bottom numbers?
All right, let's take a look at the 4. It's in position row 2, column 1, so I'm going to use row 2 times column 1 and just match up the elements. 1 times 4 plus 2 times 6 plus 6 times negative 2. Okay, any questions on matrix multiplication? All right, I'm going to let you try C times A. First of all, you need to find out if it's possible. And if it's not, just put not possible. Check the dimensions. And then come up with the product matrix. So you've discovered hopefully that it is possible because those inside numbers match. And so now work on filling in the blanks for a 3 by 3. The outside numbers will tell you the dimensions of the product matrix. And always think row times column. Row times column. Anybody stuck? Okay. I just went ahead and turned them around. You don't have to if you can see it. I like to go left to right. So I just went ahead and put C and then A and then always work left to right. So row times column. This is row 1, column 1. If you think of it this way, it may help in the beginning. So what's it going to take to come up with row 1, column 1? I'm going to use row 1 times column 1. So 4 times 0 plus 1 times 1. So my top left, row 1, column 1 of the product should be 1. Row 1 times column 1. Okay, think about this position. It's row 1, column 2, so use row 1 times column 2. 4 times 3 plus 1 times 2. That should be 14. Okay, in our answer, this is row 1, column 3, so use row 1 and column 3. 4 times negative 5 added to 1 times 6. Negative 20 plus 6 is negative 14. Anybody get those top 3 right? Very good. So now that you've seen, if you haven't been able to already, can you go ahead and work on the other 2 rows? Use the same thinking. Since this is row 2, column 1, then use row 2 of the left matrix times column 1 of the right. So it looks like what I'm seeing, it's 2, 22, and what'd you get for this row 2 column 3? Negative 18. Everybody good with row 2? Excuse me. You may have a question. Once you've done a few of these, it gets pretty easy. So it looks like row 3, column 1 of the product matrix is 3. Everybody get that? Okay. What about row 3, column 2? 0. And the last one? 28. Everybody agree? Any questions? That is matrix multiplication. All right, moving right along. Just wanted to give you a heads up here. When you see this little notation, if it's a capital I with a subscript 2, that refers to the identity matrix. Sorry for that green, it's kind of hard to see. So basically, I went ahead and told you what it is. All right, the identity matrix, just think in terms of real numbers. Remember the multiplicative identity property? What is that from years ago? Multiplicative identity says if you multiply a number times, well, that's the 0 property. Any number times 1 is itself. And we say that 1 is the multiplicative identity element. Okay. Well, in a similar way, matrices have an identity element. It's not the number 1, it's the matrix that looks like this. So if it's a 2 by 2 matrix, this is the identity element, meaning if you multiply another matrix times this, you will just get that matrix as a result. And if it's a 3 variable, then where it has a 3 here, you'd be using this matrix in that spot. Okay, so we've already done the A times C, right? Maybe look at your notes. Let's see, 28, negative 9. And then what's that bottom row? 4, 23. And now we'll do scalar multiplication. 3 times this identity matrix. That's pretty easy. So it'd be 3, 0, 0, 3. And now you just do the subtraction. And I think you could probably handle that. Adding and subtracting is really simple. But the purpose of this slide is to give you a heads up about what's this talking about. So I sub 2 will be this matrix. And if you see I sub 3, it's that matrix. Just plug it in. All right, we need to spend, I'm not going to do any more multiplication because I think you get it. I need to get to finding the inverse matrix. So I'm going to skip these 2 examples if you think you're good with multiplication. How do we find the inverse of a matrix? This is a pretty big deal in our lesson. Your book says, or the homework page that I'm going to give you, it says each matrix is non-singular, and that's just another way of saying there is an inverse that can be found. So here's how you find the inverse of a matrix. We first have to remember how to find the determinant. Do you remember how to find the determinant of a 2 by 2? Okay, so let's just go ahead and do that real fast for this example. The determinant would be 16 minus 20, which is negative 4. Okay? If this had been 0, then there is no inverse. Okay, and I think you'll see why in just a minute. To find the inverse, I'm going to go ahead and label these like I did yesterday when we were talking about finding the determinant. To find the inverse of a 2 by 2, which is really all we're going to worry about, to do the inverse of a 3 by 3, you really need a graphing calculator. So we're just going to stick with 2 by 2 square matrices. You're going to do this little formula. You're going to multiply by 1 over whatever the determinant is. So I'm going to give it to you in general terms, and then we'll plug in specifically. In general, this is how you find the inverse of a 2 by 2. So multiplying by 1 over the determinant, and then we're going to change this matrix up a little bit. We're going to switch places with these elements called D and A. I'm just going to pick them up and switch them. For the other 2 elements called B and C, I'm not changing their location, I'm changing their sign. So if they're positive, they become negative. If they're negative, they become positive. I'm going to show it like this. So that's the formula, if you will, or the definition of how to find the inverse. So let's do that with this example. We've already found the determinant. So I'm going to multiply by negative 1/4. Just put the determinant down here below 1. And I'm going to switch places with the 8 and the 2. And then I'm going to change the signs of the other two elements. And now I'm going to do scalar multiplication, negative 1/4 times every number, or dividing by negative 4, same thing. So 2 times negative 1/4, that's negative 1/2. This would be positive 5/4. This would be positive 1, and this would be negative 2. So we've seen this notation in the past. If this matrix had a name, maybe it's called matrix A. What I have found here is called the inverse of A. Anytime you see that little negative 1, looks like an exponent, but it's not in an exponent context, that reads as the inverse of A. All right? Why is this important? Why is it important to be able to find the inverse? Well, because we're building towards being able to solve matrix equations. All right? And really, this is pretty much just like we were doing in the past. Let me give you a parallel example using what you've learned even in Algebra 1. Instead of matrices in Algebra 1, you just had regular numbers. In place of this matrix, maybe just a number 2. And there was a number here in place of this matrix. So if you took the blue equation, what would your first move be to solve for x? You would subtract 5. Then your next move would be divide by 2. That would be the logical choice. Well, we're going to do that same thing. I need to first subtract a matrix. And in the blue, you would have done 12 minus 5. You wouldn't have done 5 minus 12, would you? Because that's not the same thing. You would have taken 12 and you would have subtracted 5 from it. Well, in the red, you're going to take this matrix and you're going to subtract this one from it, just like you would have done in the blue equation. So do that first. Take this matrix and subtract this matrix from it. Just match up the elements. So you do 6 minus 2, 4. The order obviously does matter because subtraction is not commutative. 2 minus 7 is negative 5. Negative 2 minus negative 3 is positive 1. And 3 minus 4 is negative 1. So does everybody see how we got to the blue step? We just subtracted. And then you gave me the next step when we were just dealing in real number equations back in Algebra 1. You said divide by 2. Well, I technically can't divide one matrix by another, but I can multiply by the inverse. So that's why we learned how to find the inverse. All right? I need to know what the inverse of this matrix being multiplied by x is. Now that you know how to do that, see if you can figure out the inverse of this. I'll give you about a minute. So look at your definition on the previous slide. Find the determinant first. Could be that it doesn't have an inverse. You can't divide by 0. So if the determinant is 0, then there is no inverse. There is no? Should be in this case because the determinant's 1. Yeah, it's great when the determinant is 1. And that's what happens here. So essentially, the determinant is 1. That means we get to multiply by 1. We just have to remember to change up the matrix. Remember that? The A and the D switch. So what is the inverse?
2, negative 7, negative 4.
Everybody agree with that? Yeah. Okay, so here's what I'm going to do. we're going to assume, I'm going to save you a step, you're not going to have to multiply by this inverse on both sides, because we know what happens when I multiply by the inverse. I'm just going to create the identity matrix, which is really another way of saying 1x. Okay? So don't worry about showing me multiplication on the left side where the variable is in this case. You just need to show multiplication on the right side using the inverse. But what I'm about to say is big, so listen carefully. Remember, matrix multiplication is not commutative. So when you find the inverse and you are now ready to multiply by the inverse on the non-variable side, the inverse has to be first. When you write these two matrices down and you're ready to multiply them together, the inverse has to be on the left. If it's not, you're going to miss this problem. Inverse always on the left. Okay, I'm going to give you just a minute. Now that you know how to do matrix multiplication, multiply these two matrices together. And that should be the missing matrix of this problem represented by X. So take a minute, see if you get it. And I got the answer up here. Is everybody able to get that? Now, your problems in the book aren't quite this elaborate. There's not as many steps, but this is more or less what I'm looking for you to be able to do on your next quiz and the semester exam. I like it because it pretty much takes a lot of what we learned in this lesson and puts it all together in one problem. All right, any questions? I need to talk about what this means. So let me give you the sheet. I didn't make a copy, and by the way, for Carly, this is going to be on Moodle. So if you lose this sheet, I didn't give her a sheet before she left, but I'm going to put this on Moodle for you if you lose this. It's front to back, and I just want to explain some problems, and then I'll give you the rest of the time to work on this. Because it is a little, I'm not a big fan of how they did this, but it's, once you see it, it's not too bad. Let's take a look at number 31 on the back side. Oh, and I'll leave you out. It wasn't intentional. Number 31, you see that the directions are to find the inverse. Well, you know how to do that. Okay. Look at number 41. Do you see that number 31 is the coefficient matrix for number 41?
Yes.
So here's the deal. When you find the inverse for number 31, you're going to use that to multiply on the right side for number 41. So you don't have to find the inverse twice. You might be thinking when you get to number 41, make it a matrix, find the inverse of the coefficients. Well, you've already done that when you did number 31. So number 31 and number 41 correspond to each other. Look at number 32. Do you see how number 32 really matches up with 42? It's the coefficient matrix. So that inverse that you found for number 32, you'll just put it on the right side of the equation and multiply by the matrix 8, 4. And make sure the inverse goes on the left. Does that make sense? All right, and you're not doing any of the 3 by 3 matrices. It's all 2 by 2s. So did I give you a slide with the problems on it already? Okay. And if you have a question about that tonight, by the time I see your email, it's probably going to be late with baseball, but I'll respond as soon as I can if you have questions about this sum. Or you can see me in the morning. I think they should be up there. It's just a different number. It's still number 33. You see that? So, yeah, you shouldn't have to find the inverse again. From when you get down to solving, you should be able to find an inverse that you've already found. Use that to solve those equations or those systems. All right. I'll let you get started, and if I can help you, let me know.